Hello, we are going to see testing of hypothesis for paired t-test in this session. So let us uh, quickly move to the question. The question given here is: you send your salespeople to a customer service training workshop. Has the training made a difference in the number of complaints? You collect the following data. The data is given here and consider 1% level of significance. In this case, we have 5 salespeople A, B, C, D, E, and we have number of complaints before the training session and after the training session. So this data is given to us, and they're asking us to find out has the training made any difference in the number of complaints. So we cannot generally make a statement based on the question values given here. For 5 people, maybe we could tell if it has made a difference or not made a difference by just glancing at the data. But if it is thousands of people or thousands of complaints, okay, so there it becomes necessary for us to apply a statistical tool and give a judgment or predict if yes, the training has made an impact, or no, the training has not made any impact. So that is the reason why this paired t-test is important for us. So let us uh, quickly start with the procedure of testing of hypothesis. The first step according to the procedure is to write the null hypothesis and alternative hypothesis. So null hypothesis is denoted by H0. So here we are checking the mean values of before training program and after training program. Okay, so the mean values before training program are equal to mean values after training program. Now here what we are conveying in this null hypothesis is that there is no significant difference between the mean values of the complaints before the training and after the training. Okay, and H1 will be contradiction to this. So this mean values before training are not equal to mean values after training. Okay, so here we are either telling that there is no difference at all in the mean values and there is a difference. If there is a difference, it is a good thing. It is secondary if the difference is positive or negative. But initially, let us find out if there is a difference, if there is an impact. Okay, so in the same step, we will also find out what kind of test. So it is not equal to, symbol here is not equal to, that means it is a two-tailed test. Alright, now the second step is the level of significance. Now in the question they have asked us to assume level of significance as 1%. So alpha will be 0.01. For all the questions previously we have considered level of significance as 5%. So this is something which is different. So please focus. Next, step 3 is to calculate the test statistics. So tcal is equals to d bar by standard deviation of the difference by root n. Now what is this d? Okay, now let us write down. D bar formula is summation di by n. Standard deviation formula with respect to the difference here, I'll tell you what is the difference. Square root of summation di minus d bar whole square by n. Okay, so we have discussed mean and standard deviations in unit 1. Please refer your notes for unit 1. You will understand the calculation of standard deviation. Now what is d? Okay, now we have sales people A, B, C, D and E. So before and after values complaints are given here. Before is 620 304. Now here it is 46200. Okay, whatever data is given to us in the question, I have written it like this. Now the d value, d is nothing but the difference in complaints. 4 minus 6 is minus 2, 6 minus 20 minus 14, 3 minus 2 minus 3 minus 1, 0 minus 0 0, 0 minus 4 is minus 4. Okay, now summation di minus 2 minus 14 minus 1 minus 4 is minus 21. So this is equals to minus 21 by number of, what is the sample size? You only have 5 sales people here. So which is equals to minus 4.2. Now let us calculate the standard deviation. So di minus d bar whole square. So di is minus 2, d bar is minus 4.2 and squaring. So di is minus 2, minus of minus is plus 4.2 is 11.5, squaring we get 4.84. So this is 4.84. Next, minus 14 minus of minus 4.2 is minus 49, that is minus 9.8. Square of minus 9.8 is 96.04. Then we have minus 1 minus of minus 4.2, 3.2, square of 3.2 is 10.24, and this is 0, 0 minus 4 minus of minus 4.2, square of 4.2, 17.64. Then minus 4.2, sorry, this is minus 4 minus of minus 4.2, 1.5, square of 0.04. Okay, so these are the values. Now we summate all these values, we get 4.84 plus 96.04 plus 10.24 plus 17.64 plus 0.04, which is equals to 128.8. Okay, now substitute the values in standard deviation formula. Standard deviation is equals to summation of all these things is 128.8 by square by n is 5. Okay, so 128.8 by 5, this equals to 5.075. Okay, now we have d bar, we have standard deviation, and we also have the value of n. Let's just substitute it here. T cal, this is 5.075, T cal is equals to d bar is minus 4.2 by standard deviation is 5.075 by square root of 5. So let us see, minus 4.2 by 5.075 by square root of 5 minus 1.85. This is minus 1.8505. Okay, so the calculated value is minus 1.8505. Now step 3 is done. Now let us go for the step 4. Step 4 is to find out the T critical value. Now when the critical value, so here in step 4 we are supposed to find out the critical value. Now because we are using T distribution here, we need different degrees of freedom. The degrees of freedom in this case can be calculated with the formula n minus 1. N is 5 here, 5 minus 1 is 4, and the level of significance is 1%. So T tabulated value at 1% level of significance and 4 degrees of freedom is equals to, we have to find this value. So in the table, if you see, we are doing a two-tailed test. In the beginning, step 1, we have identified it is a two-tailed test. Now at 1% and 4 degrees of freedom, the value is 4.604. Okay, So this is 4.604. Okay, now this is done. In this here in the same step, we have to draw the distribution curve, and we have to plot the critical region and the acceptance region. Okay, so here let us assume this is a symmetrical curve, and this line is dividing the graph into two equal halves. So it is a two-tailed test. The critical region exists on both the sides, this side and this side. Okay, so negative, we'll give the values on both the sides. This is going to be minus 4.604, and this is going to be plus 604. Okay, and the remaining, this is the acceptance region. So where does minus 1.80 fall in the graph? So it falls towards the acceptance region, right here in this part, maybe around, if this is 0, this is minus 1.085, isn't it? So this is falling in the, this is the rejection region, and this is the acceptance region. So it is falling in the acceptance region, hence we accept H0. Hence we accept H0. Now what is H0? H0 is there is no significant difference of the training before and after. Okay, so the impact of training is null. There is no difference at all. But the complaints before and after are more or less same. The mean values are more or less same. That is the reason this has been proved. Okay, this is how you calculate the t-test. In the next session, we are going to discuss chi-square test. Thank you.